Hi everybody, my name is Kate and welcome to another Saturday session with ExamRevision. So today we're going to look at the topic of logs and indices for Leaving Cert higher level maths. So by the end of this session, what should you be able to do? So hopefully you'll be able to use the laws of logs and indices to solve equations. All of these rules are given to you in your formula book. Okay, so we're just going to practice using them. There's very little you need to learn off by heart for this chapter. And we're also going to use the same rules to solve real life problems, which is a super common exam question. We'll do some practice of those later. So we're going to divide this session up. First, we're going to just practice using the laws of logs and indices, and then we'll bring them into the real life examples. Okay. And then throughout, anytime there's a past paper question that's linked to one of the examples, we'll go through that as well. Okay. This will help you see how it was examined in the past and maybe how it might be examined again in the future. Okay. Because the questions, especially the real life problem questions, are quite similar. So first, this is the most important page when you are studying logs and indices. Okay, it's page 21 of your formula book. When you're doing practice questions, it's really important that you have this page open in front of you. It can look a little bit overwhelming, so you need to practice using it, figuring out which formula you need to use. Okay, so down the left-hand side, we've all the formulas for our indices. In the middle, we've all our formulas for the logs. And then on the right-hand side, in the top corner here, I would say this is one of the most important formulas. Okay, we're going to use this a lot. Sometimes it's forgotten about, okay? But this formula allows us to move between logs and indices, okay? We're going to need that quite a bit towards the end of questions when we're solving, when we're getting at our final answer. Okay, so just keep that formula in mind. Sometimes people can forget about it. It's really useful. So that formula is going to be super important, as are the rest of them. But I would say this one, keep an eye on that. We will be using that one quite a lot. Now we're going to look at our first example where we have a few of the laws of indices that we've just looked at all combined into one question. So how this question would be phrased, the question would say solve for x. So at the end of the day, we want x equal to a number. Immediately when I look at this question, I notice that we have different bases. So we have one base of 8 and one base of 2. That won't work with the rules. So what we're going to do, we are going to change them all to base 2. So I'm going to do a little bit of rough work over here to the side. I'm going to take 8 to the power 4 over 3. I don't want that to be a base 8, I want it to be a base 2. So then I think 2 to the power of what is equal to 8? 2 to the power of 3. And we still have our 4 over 3 outside. Okay, then I look at my rules and we're dealing with this rule here. So we're going to multiply the powers. So it'll be 2 to the power of 3 multiplied by 4 over 3, which is 2 to the power of 4. So instead of writing 8 to the power of 4 over 3, I can just call that 2 to the power of 4. Similarly with the square root of 2, this is the rule you need to kind of learn off. Okay, that's 2 to the power of a half. Okay, now I'm going to rewrite my question. So instead of 8 to the power of 4 over 3, I'm writing 2 to the power of 4 is equal to 2 to the power of 5x minus 2 all over 2 to the power of a half. Now I look at my rules again. We see we have a division. Okay, the bases are the same, so we can go ahead and use that rule. So it'll be 2 to the power of 4 is equal to 2 to the power of 5x minus 2 minus a half. Okay, where did that half come from? We're dividing, so you subtract the powers. Now we're going to simplify that up a little bit. So that'll be 2 to the power of 5x minus 2.5. Now, what you'll notice here, when we have the bases the same, and there's one at either side, what we can do, we can actually ignore them. Okay, and we can just let the powers equal to each other. So I'm going to say that 4 is equal to 5x minus 2.5. Okay, I'm going to get rid of this minus 2.5, so we'll add it to the other side. So that'll be 6.5 is equal to 5x. So x is equal to 6.5 divided by 5. That works out to be x is equal to 1.3. Okay. That's your answer. What you can do is you can sub that x. If you want to check your work, you can sub the x in here and you should get out the same answer as this. So you should get out 16 when you sub in 1.3. That's kind of a handy way just to check that you're correct. So we're going to start at looking at some relatively straightforward examples where we just use the laws of indices. So first we have 10 to the power of 7 multiplied by 10 to the power of 5. Okay, so we go to our rules, we see, okay, the first one here, that deals with multiplication. So they have a to the power of p multiplied by a to the power of q. What do? They just add the powers. So we're going to do the same thing here. So this is going to be equal to 10 to the power of 7 plus 5, which will be 10 to the power of 12. Okay, same thing for number 2. We are going to match what our question looks like with one of the laws. Okay, so we have a fraction in a bracket all raised to a power. Same thing as down here. Okay, so we're going to write this. Here we can see that the power p went to the numerator and to the denominator. So we'll do the same thing. So this will be 4 squared all over 5 squared, which would be 16 all over 25. Okay, now next one, we have a power raised to a power. So this looks like rule 3 here. So what do they do here? So they have a power raised to a power, so a to the power of p, all to the power of q, and they multiplied the powers. Remember, when we have two things squished together like that, it means multiply. Okay, so we're going to do the same thing. So that will be y to the power of 3 multiplied by 6, which is y to the power of 18. Okay, next one, z to the power of 0. This is a very specific rule. Okay, so rule number 4 here. Anything to the power of 0 is 1. Okay, sometimes people think, okay, anything to the power of 0 must be 0. It's quite a common mistake, but just make sure it's a rule that's in your formula book, but you can also check it on your calculator. So if you put in, 6 to the power of 0, you'll get out 1. If you put in 102 to the power of 0, you get out 1. Okay, every single number to the power of 0 is 1. Okay, now things get a little bit trickier for question 5. Okay, so this looks like, well, it is multiplying. Okay, so we are going to end up using law 1 up here. Okay, but it's not that straightforward. So if you notice with this, okay, the bases are the same. What I mean by the bases is the big number. So it's a to the power of something multiplied by a to the power of something. Okay, but here we've 2 to the power of something multiplied by a to the power of something. So the bases aren't the same. So what I'm going to do, I'm going to do a little bit of rough work down here. So I want my bases to be the same. So I want to write 8 as 2 to the power of something. If you do a little bit of playing around with your calculator, you'll find out that 8 is the same as 2 to the power of 3. So I rewrote 8 as 2 to the power of 3. I still need to keep this 5. So it'll be 2 to the power of 3, all to the power of 5. Then look up here, we're going to be using law 3 again. So we multiply our powers. So that'll be 2 to the power of 3 multiplied by 5, which would be 2 to the power of 15. Okay, now make sure that's not our answer. That was just a little bit of rough work. So now I'm going to go back up to my question. Okay, 2 to the power of 3 can stay the way it is. And instead of multiplying by 8 to the power of 5, I'm going to multiply by 2 to the power of 15. Okay, now we're back to our straightforward multiplying because our bases are the same. So we can just add the powers. So that'll be 2 to the power of 18. Okay, the example number 6 then is going to be relatively similar. Okay, when it comes to square roots, okay, so this bottom one down here, okay, we're going to change them to indices. We don't really know much about square roots. So we're going to change them both to indices. So we'll deal with this, the fourth root of 3 first. We'll look at this rule here. Okay, so we have something that looks like this. We're going to change it into something that looks like that. So instead of writing the fourth root of 3, we're going to write 3 to the power of 1/4. Okay, so that rule going from there to there is in our formula book. What isn't in your formula book is for square roots. Okay, so you kind of need to learn off that square root is the same as to the power of a half. So that's the same as 81 to the power of a half. So you need to learn a square root with no number sitting here is to the power of a half. That comes up in a few places on the course, so just be careful of that. Okay, now this looks like it's going to be a dividing question, so I'm keeping this rule in mind, but I'm also thinking, okay, my bases aren't the same. So how do I get my bases the same? I'm going to do a little bit of rough work over here. So I have 81 to the power of a half. I want to turn that 81 into 3 to the power of something. Okay, how do I know 3? I know my bottom base is 3, so that looks like our likely number. Okay, play around with your calculator, you'll find out that 3 to the power of 4 is 81. Okay, and we still have that half outside. Okay, now we have a power raised to a power, so we're going to be using rule number 3. So that will be 3 to the power of 4 multiplied by a half, which will be 3 to the power of 2. Okay, so instead of 81 to the power of a half, I can write 3 to the power of 2 over 3 to the power of a quarter. Now my bases are the same, so I can subtract my powers. Okay, that's using this rule here. Okay, so that's the same as 3 to the power of 2 minus 1 quarter, which is 3 to the power of 7 over 4 as our final answer. Okay, so that's just some practice using the rules, knowing where to find them. Just be careful with example 5 and 6. It's really important that when you're applying the rules that it matches up exactly with the rule. Okay, so the bases have to be the same is kind of the key point for this section. This will be the last indice question that we look at before we move on to logs. It's a little different, this question. So what we're going to do, we're going to do some manipulation to turn it into an algebra problem. And then from there, it's just pure algebra. Okay, so we have 2 to the power of 2x plus 2 minus 33 multiplied by 2 to the power of x plus 8 is equal to 0. So with these type of questions, you pick out the indice with the simplest part. Okay, so the nicest looking indice, so it's 2 to the power of x. And what we're going to do, we're going to let 2 to the power of x equal y. So really what we want to do, we want to get rid of anything 2 to the power. Okay, and we're going to substitute that with y. So that will be quite easy. So at the start, we'll do 2 to the power of 2x plus 2 minus 33y plus 8 is equal to 0. Now I still have this. This looks quite messy. So we're going to take this off to the side. So we have 2 to the power of 2x plus 2. Now really what we're going to do here, we're going to use some of our laws. We're going to use them backwards. So right now we have something that looks like this. So we have a base with powers being added together. So we're going to go backwards. Okay, and we're going to split it up. So we're going to say that this is the same as 2 to the power of 2x multiplied by 2 to the power of 2. Now, that's the same as 2 to the power of 2 is 4 multiplied by 2 to the power of 2x. Now I'm getting there. Remember, I want to change this into just 2 to the power of x, and then I can just replace it with y. So we're just manipulating it here. We want to make something that looks like 2 to the power of x. Now we're nearly there, but we have a 2 stuck in front of it. So what we're going to do, we're going to use this rule here. So we have something that looks like this. So we have 2 to the power of 2x. We can split it up and put the 2 outside the bracket. So we have 4 by 2 to the power of x, all multiplied by 2. So it kind of worked backwards there a little bit. And now 4, 2 to the power of x, we can replace that with y. So it'll be 4y squared. Okay, so just a little bit of manipulation, working backwards with the formulas. We hadn't seen that in the other examples. We were always going this way. In this question, we need to use our rules, but backwards. So now we're going to rewrite our question. So instead of 2 to the power of 2x plus 2, we're going to write 4y squared minus 33y plus 8 is equal to 0. Now you'll notice what we're left with is a quadratic. Okay, so very quickly I'm going to do out the minus b formula for it. So I'm going to say that y is equal to minus b, which is minus 33, plus or minus the square root of b squared, which is minus 33 b squared minus 4 by a by c, which is 8, all over 2 by 4. Okay, if you're stuck in the minus b formula, go back and revise it. You could also potentially do this by factorising, but it might be just a bit tricky to see. I'm going to pop that straight into my calculator. So you got y is equal to 8 or y is equal to 1/4. Now, some people might think that that is our answer. Okay, we need to go back up. So it said solve. Okay, we had x in our question. So we want our answer to be x is equal to a number. Okay, but if you go back up to this line, we let y equal 2 to the power of x. And we have y is equal to 8 down here. So we know y is equal to 2 to the power of x. Y is equal to 8. So we can say that 2 to the power of x is equal to 8. Now, I need to think 2 to the power of what is equal to 8. Okay, 2 to the power of 3 is equal to 8. So x is equal to 3. Okay, that was quite straightforward because we could think about it in our head and figure it out. The other answer, y is equal to 1/4, might be a little bit trickier. So we have 2 to the power of x equals 1/4. Now, here we've different numbers, so I want to rewrite this 4 as something to the power of 2. So we have 2 to the power of x is equal to 1 all over 2 squared. Okay, and what we're actually going to end up using here is this rule. So if you have a fraction with 1 on top and a base to a power on bottom, what you can do, instead of writing 1 over 2 squared, you can write that as 2 to the power of minus 2. Okay, so now we have 2 to the power of x equals 2 to the power of minus 2. Ignore the bases because they're the same, so we end up with x is equal to minus 2. So x is equal to minus 2 or x is equal to 3 are our two possible answers. Okay, they should both work if you sub them back in into this equation here. They should come out to give you the right answer. They should verify that the left-hand side is equal to the right-hand side. So this is another similar question to the last one, using nearly all of the laws of indices. So if you want to pause the video here and give it a go, use the method we just used, we should get out the right answer. Okay, so first thing when I look at this question, I see that there are different bases. So we have a 25, a 125 and a 5. So that's not going to work. So immediately I think, okay, I'm going to have to change them all to the same base. What will work? So it's usually the smallest number that will work. So I'm going to change everything to base 5. So 25 to the power of x, that won't work. I think, how could I write 25 as 5 to the power of something? I could say 25 is 5 squared. Okay, and we still have that to the power of x. And we know by now we're going to use law 3 here. When you have a power raised to a power, you just multiply them. So that'll be 5 to the power of 2x. Okay, same now with the square root of 125. Okay, we know square root is the same as to the power of a half. Okay, so square root of 125 is 125 to the power of a half. Getting there, but not fully there yet. So now we need to change 125 to 5 to the power of something. So 125 is 5 cubed. And we still have the power of a half outside. And that will equal, when we multiply the powers, that'll be 5 to the power of 3 over 2. Okay, and then the last one, we have the cubed root of 5. You can see this in our formula here. So we have something that looks like that. We're going to turn it into 5 to the power of 1/3. Okay, now I can go back to my formula or my question. 25 to the power of x, instead of that, we're going to write 5 to the power of 2x is equal to square root of 125. We're going to write 5 to the power of 3 over 2. And instead of the cubed root of 5, we are going to write 5 to the power of 1/3. All to the power of 12. Now, what we need to do now is we need to subtract the powers. So we are going to say, for this division here, so we have 5 to the power of 2x is equal to 5 to the power of 3 over 2 minus 1/3. And that's all to the power of 12 still outside. So I'm just using my subtraction rule here because we're dividing. So that is equal to, just pop that into your calculator, so 3 over 2 minus 1 over 3. That will give you 5 to the power of 7 over 6. We still have our 12 outside the bracket. And to get rid of that bracket, we're going to multiply those powers. So 5 to the power of 7 over 6 multiplied by 12 gives me 5 to the power of 14. Okay, now again, we have our bases equal to each other. Okay, so when that happens, you can just let the powers equal to each other. So we have 2x is equal to 14, so x is equal to 7. Okay, that's our final answer there. That's a really good question. If you want to check if you understand all the laws of indices, that question nearly has them all in it. Okay, so we get out our answer, x is equal to 7. Again, you could check that answer by subbing it in, and you should get the same thing for both sides if you want. Now moving on to logs, we're just going to start with some fairly basic examples again, just using the formulas. So we'll look at the first question. We've log to base 2 of x plus log to base 2 of x plus 3. So you go to your formulas and you say, okay, I have something that looks like this. So what am I going to do? The x and the y, when the logs are being added together, you can change it to being multiplied together and just write the log once. So this will change to log to base 2 of x multiplied by x plus 3. So we just multiply out those brackets. That'll be log to base 2 of x squared plus 3x. Okay, similarly for question 2, we can see we have log of 2x minus log of x. Okay, what you'll notice here, there's no bases. When they don't write in a base, there's really a base 10 there. Okay, if they don't write in the base, that's fine. You can assume that it's log to base 10. Okay, but that doesn't make a difference, and your calculator will understand that as well. Okay, so when we have a subtraction, we have a rule here. So the x and the y, they get divided by each other. So we're going to do the same thing. So we'll have log of 2x over x, which is just log of 2. Okay, and then example 3, this is a really important rule. Okay, so if you've log to base 2 of 2, you can actually put that into your calculator to see what you'll get out. Log to base 2 of 2, you just get out 1. Okay, now that was an easy example because I could check it on my calculator. But if you had something like log to base y of y, okay, that will also equal 1. Okay, or log to base x of x, that will also equal 1. We're going to see that in one of the questions later on. So these are just kind of going through the basics of how to use the formulas. Make sure you know this before we move on to the slightly trickier problems now in a second. Okay, so just find the formula that matches, make sure it matches exactly, and then you can apply it. Now, before we move on to solving problems with logs, so solving for x, we need to figure out how to move between logs and indices, because that's going to be really important for solving. Okay, so this is the formula that I mentioned at the start that was going to be super important. This is the key to a lot of questions. Okay, so if we look at our first problem here, we're solving for x. Okay, we want to find out what the x is. Now, if the x is trapped in an indice, okay, or in the index, if it's the power, what you need to do, you need to change to logs. Okay, how do you do that? We're going to use this rule up here. Okay, so we're going to match it up. Okay, I'm going to use a different color here. Okay, this is my a, this is my x, and this is my y. Okay, so we're going to change that. So that'll be log to base 3 of 9 is equal to x. Okay, what did I change that to? I changed that to log to base a of y is equal to x. So you need to get used to kind of swapping between them. Okay, the numbers move around, just make sure you move them around correctly. Okay, so just make sure now, this is just a number, I can just put that into my calculator. So log to base 3 of 9 is equal to 2. So 2 is equal to x. Okay, now we may have been able to spot that anyway. 3 to the power of x is equal to 9. X has to be 2. But that was an easy example. You'll need to be able to do it more difficult ones where you won't be able to spot it straight away. So here then the next question, we're solving for x again, but this time our x is stuck with a log. Okay, if it's stuck to a log, what you need to do is change to index. Okay, or change to an indice. So again, we're going to be using this rule up in the top right hand corner. So what we have at the moment, we have the right hand side of it. We have something that looks like that. So this is our a, this is our y, and this is our x. Okay, and we want to change it into a to the power of x is equal to y. Okay, so we have 2 to the power of 3 is equal to x squared minus 2x. 2 to the power of 3 is 8, so we have 8 is equal to x squared minus 2x. At this point now, I'm seeing an x squared and I'm seeing an x and a number. Immediately I'm thinking quadratic. Okay, so I'm going to make it look like a quadratic. So I'll have x squared minus 2x minus 8 is equal to 0 just by bringing everything to one side. Now, you can do the minus b formula here. This is fairly straightforward, so I'm going to do it using factorising. But if you find that difficult, which some people do, just go off and use the minus b formula. It doesn't take that much longer. Okay, so we have x at x, and we want to make minus 2 using the factors of minus 8. So I'm going to put a minus 4 and a plus 2. Okay, so then I end up with x plus 2 is equal to 0, x is equal to minus 2, and x minus 4 is equal to 0, x is equal to 4. Okay, now with logs, sometimes it's worth checking if your solutions work. So I'm going to sub in both those answers. So log to base 2 of minus 2 to be squared minus 2 by minus 2. So I'm just going to pop that into my calculator. So log to base 2 of minus 2 squared minus 2 by minus 2 is equal to 3. So this one works. And we'll do the same thing here. So log to base 2 of 4 to be squared minus 2 by 4 is equal to... Okay, that also gives me 3. So both my answers are correct. Okay, we might see later that sometimes if you get out a certain number, it just won't work with the log, because what's after the log, so this bit here, can never be negative. So sometimes you might have to discount one answer. Not the case here, but it's all. So now we should have enough preparation done to solve a question using our log rules. Okay, so this question here would say something like solve for x. So we're given log to base 2 of x plus 1 is equal to 5 minus log to base 2 of x minus 3. Okay, so first thing, anytime we see a log question, we go to our formulas. We see, okay, all of these formulas, they deal with logs when they're at the same side. Okay, so basically we need to rearrange this. In general, if we have logs, if we have two logs, we want them at the same side of the equal to sign to use our rules. Okay, so I'm just going to rearrange this. I'm going to bring this over here and it'll change to a plus. That'll be log to base 2 of x plus 1 plus log to base 2 of x minus 3 is equal to 5. Now this matches up perfectly with rule number 1 here. We have two logs with the same bases being added together, which means we're going to multiply the bits that come after the logs. So it'll be log to base 2 of x plus 1 multiplied by x minus 3 is equal to 5. Now what I'm going to do, I'm going to multiply out both of these brackets now. So I'm going to say that that is the same as log to base 2 x by x and x by minus 3. That'll be x squared minus 3x plus x minus 3 is equal to 5. Then we've log to base 2 of x squared minus 3x plus x and minus 2x minus 3 is equal to 5. Okay, now I have my x trapped inside the log. There's no more rules of logs that I can use over here. When you kind of get to this dead end, you know we need to change then to index form. Okay, so I'm just going to label my parts here. So right now I have something that looks like log to base a of y is equal to x. This is my a, this is my y, and this is my x. We're going to go backwards. We're going to say ax is equal to y. So it's going to be my a, which is 2, to the power of my x, which is 5, is equal to y, which is x squared minus 2x minus 3. Now 2 to the power of 5 is 32. So 32 is equal to x squared minus 2x minus 3. Now this is looking like a quadratic, so what I'm going to do, I'm bring everything to the one side. So it'll be x squared minus 2x minus 3 minus 32 is equal to 0. So x squared minus 2x minus 35 is equal to 0. Okay, now we have a quadratic. You have two options when you get this far. You can either use the minus b formula or you can factorize it. I'm going to factorize this one, but if you find that difficult, just go off and use your minus b formula. So we'll have two brackets, x and x. We need to make factors of minus 35. That will add to give me minus 2. That will be minus 7 and plus 5. So that gives us x minus 7 equals 0. So x is equal to 7. Or x plus 5 is equal to 0. So x is equal to minus 5. Okay, now for some of these questions there will be two solutions, for some there will not. Okay, so what I'm going to do, I'm going to check. I'm going to do a quick check. So I'm going to sub in 7. So I'm going to say log to base 2 of 7 plus 1 is equal to 5 minus log to base 2 of 7 minus 3. Okay, I'll put in the left hand side into my calculator. So that'll be log to base 2 of 7 plus 1. That gives me 3. And then 5 minus log to base 2 of 7 minus 3 also gives me 3. Okay, so that means x equal to 7 is a solution. Now, I'm going to try the other one. So log to base 2 of minus 5 plus 1 is equal to 5 minus log to base 2 of minus 5 minus 3. Okay, now I'm going to try and put that into my calculator. So log to base 2 of minus 5 plus 1. Okay, when I try and put this into my calculator, I get out an error. Okay, why do I get out an error? It's because you can never have a negative number inside in the log. So this here can never be negative. -5 plus 1 gives me -4. Can't get the log of a minus number. So basically what we need to say then, is I'm going to cross this out. And we're going to cross this out and mark it as not a solution. So this is another similar question. Again, we need to do a bit of manipulation before we can match it up directly with the rules of logs. Okay, so we've logged 2 times log to base 3 of x plus 2 minus log to base 3 of x plus 1 is equal to log to base 3 of x plus 5. Now, first I'm going to look at this section of my question. Okay, so that matches up really well with rule 2 here. So we've log, so with the same bases, and we're subtracting. So what I think we're going to end up doing at some stage is we're going to end up dividing x plus 2 by x plus 1. Now, the only issue is there's a 1 in front of both of these logs here. Okay, but we have a 2. Okay, the rules have to match up exactly. So what I need to do, I need to get rid of that 2. Okay, what I can do here, I can use this law here, which we haven't actually used yet. Okay, so if there's a number down in front of the log, so here there's a q, what you can do, you can move it and it can become a power. Okay, so we're going to do just that. So instead of 2 times log to base 3 of x plus 2, we're going to say that's log to base 3 of x plus 2 to be squared. Okay, and then we still have our minus log to base 3 of x plus 1 is equal to log to base 3 of x plus 5. Now our rule matches up exactly with law 2 here with the subtraction. So we can divide. So we'll have log to base 3 of x plus 2 to be squared divided by x plus 1 is equal to log to base 3 of x plus 5. Now, once you get to this stage, if you have logs with the same bases at either side of the equal to sign, you can get rid of them. Okay, and we're just going to equate the bits after the logs then. So you will have x plus 2 all to be squared all over x plus 1 is equal to x plus 5. Okay, I don't like that fraction, so I'm going to bring this over to the other side and it's going to multiply. So we have x plus 2 to be squared is equal to x plus 5 multiplied by x plus 1. I'm going to multiply things out here. Okay, so this is good revision of your algebra as well. If you want to square a bracket, so if we've x plus 2 to be squared here, you have 2 options. There's a little bit of a shortcut. So you can square the first, that'll be x squared. You can square the second, 2 squared will be 4. And then we multiply the 2 of them together. So x multiplied by 2 will give me 2x, and double it, that'll be plus 4x in the middle. So my rule there is square the first, square the second, multiply the 2 of them together and double it. If you don't like that, you can just write it out twice and do your normal multiplying. You'll get out the same answer. Okay, so here instead of x plus 2 to be squared, it's x squared plus 4x plus 4 is equal to, that'll be x squared plus x plus 5x plus 5, which will be x squared plus 4x plus 4 is equal to x squared plus 6x plus 5. Now I see here I have an x squared at both sides of the equal to sign. Okay, so they are just going to cancel each other out. So both of those x squareds will go. Then I'm left with 4x plus 4 is equal to 6x plus 5. Bring x's to one side, numbers to the other side. So I'll have minus 2x is equal to 1. So x is equal to minus a half. This is going to be the last example we're going to look at now before we jump into the exam questions. But we should notice something different about this question. Okay, so we've log to base 16 of x plus log to base 4 of x plus log to base 2 of x is equal to 7. Now, the issue here is all of our rules about logs, okay, they need the same bases. Whereas here we have 3 different bases. Okay, so we need to change them to be all the same one. This is going to be our rule that we're going to use. Okay, so it's log to base b of x is equal to log to base a of x over log to base a of b. Okay, a is the base we want. Okay, and b is the old base. Okay, now we're going to change everything. We usually change everything to the smallest base. So we're going to change everything to log to base 2. So I'm going to take all the parts separately. So first I'm going to take log to base 16 of x. Okay, so log to base 16 of x. Okay, b is our old base. Okay, so b is 16. And a is the base we want. So we're going to change it to base 2. How did I pick 2? We usually go with the smaller number. Okay, or the smallest possible base that we want to match it up with. It doesn't make a huge difference, but we'll go with 2. So we'll change this to log a from our formula. A is the base we want, so that's 2 x all over log to the base we want over with our old base. Okay, so we've log to base 2 of x. Now this is just a number. Okay, so we're going to put that into our calculator. So log to base 2 of 16 will give me 4. Okay, another way of writing this will be a quarter log to base 2 of x. Okay, so this here is important. Let's highlight that for a second. We're going to be coming back to that. We're going to do the same thing now with log to base 4 of x. Okay, so this is our formula we're using again. So log, this time a is the old base, which is, a is the base we want. We want base 2. And then log to base 2 of b, our old base, which is 4. This is the same as log to base 2x all over 2. Another way we can write that as a half log to base 2 of x. Okay, so now what we're going to do, we're going to rewrite our question because now we have everything with the same base. So we've a quarter log to base 2 of x plus a half log to base 2 of x plus log to base 2 of x is equal to 7. Now here, this is quite a tricky question because you need to spot this next step. Okay, so what do we notice about this question? So this is a log to base 2 of x, this is log to base 2 of x, and this is log to base 2 of x. Okay, so we have a quarter log to base 2 of x, we have a half log to base 2 of x, and we have 1 log to base 2 of x. Because they're all the same thing, we can add them together. So a quarter plus a half plus 1 is 1.75. So we have 1.75 log to base 2 of x is equal to 7. Now be careful, why could I do that? I could only do that because they're all the same. Okay, so I have a quarter of it, I have a half of it, and I have 1 of it. So in total, how much do I have? Okay, now here, I like my log on its own, so I'm going to get log to base 2 of x is 7 divided by 1.75. So log to base 2 of x is equal to 4. Okay, now here we're going back to that important rule again. I'm looking for x, but that x is stuck inside in the log, so I need to use this formula to get it out of it. Okay, so I'm just going to label my different parts here. So this is my a, this is my y, and this is my x, and we're going to change it into a to the power of x is equal to y. Okay, so it'll be 2 to the power of 4 is equal to x. 2 to the power of 4 is 16. So x is equal to 16. Now we're looking at some exam questions from now on. So this was actually a past mock question. So basically it's a spot the mistake question. So the question is, when asked to solve for x in the equation 2 log to base a of x is equal to log to base a of 25 minus log to base a of 9, a student gives the following solution. Identify 2 errors and outline the correction, but we don't need to solve it. Okay, so we're just going to go through step by step and see what they did and maybe correct to what they should have done. So the first line there, they just read out the question. That's fine. And then in the second line, they say that log to base a of 25 minus log to base a of 9 is equal to 16. Now, what they should have done there, okay, when we have minusing the same bases, you divide, okay, but they subtracted. Okay, they said 25 minus 9 is 16, but then instead they should have divide. Okay, so they said that log to base a of 25 minus log to base a of 9 is equal to log to base a of 16. Okay, that's wrong. What should we have said instead? We should have said that log to base a of 25 minus log to base a of 9 is equal to log to base a, and we're going to use that rule 2 up there, of 25 divided by 9. So that's error 1. Then error 2 here. So they had 2 log to base a of x, and they said that was equal to log to base a of 16. And then in the next line, they got rid of that 2. What did they do? They divided 16 by 2 to get 8. Okay, that's not correct. What should they have done there? That we should have used this rule here. So if you need to get rid of a number in front of the log, what you do is you make it a power. Okay, they divided by the 2, but you're not allowed to do that because this 8 is kind of trapped inside the log, or that 16 is trapped inside the log. So you can't divide it by 2 to get 8. Okay, so their mistake was that they said that 2 log to base x is equal to log to base a of 16. They divided by 2. So they said log a of x is equal to log to base a of 8. Okay, you're not allowed to do that. So what they should have done instead, they should have said that log to base a of x okay, so they have 2 log to base a of x. What they should have said that's equal to is log to base a of x squared. Okay, and then they would have ended up with log to base so log to base a of x squared is equal to log to base a of 8. Okay, if you did want to solve that from there, then we've logs at both sides. You could have gotten rid of the logs, but we're not actually asked to solve it in this case. Okay. So now moving on to the 2021 log question. Now at first glance this question looks a little tricky, but we're going to work through it nice and slowly, use our logs, use what we've learned, and then hopefully it should make sense. So the real variables y and x are related by y is equal to 5x squared. Okay, so that's obviously going to be a key bit of information. Put a mark under that. So part 1 says the equation y is equal to 5x squared can be rewritten in the form log to base 5y is equal to a plus b log to base 5x. Find the value of a and the value of b. Okay, so obviously we're going to have to introduce the logs here. So first we'll start with what we've written. So we've y is equal to 5x squared. Now, I want to make this, okay? What I can do is, as long as I do it to both sides, there's absolutely no problem with it. So we obviously need to introduce log to base 5 into this equation. So we're going to do that to both sides. So we've log to base 5y is equal to log to base 5 of 5x squared. You know, there's absolutely nothing wrong with that. We've put log to base 5 at both sides, so we haven't changed the equation. Now, we have the left side here. We have this, so we're off to a good start. Now, we need to end up with 2 things on the right-hand side. So this here somehow needs to split into 2 things. Okay, so I go to my rules and I think, what could I possibly do? So right now, I actually have something that looks like this. Okay, so I've log to base 5 of 5x squared. Okay, what do they do here? They split up the x and the y. All right, so they split up the x and the y. So we're going to do the same thing. We're going to split up our 5 and our x squared. So that gives us log to base 5 of y is equal to log to base 5 of 5 plus log to base 5 of x squared. Okay, getting a little bit closer now. At least we have 2 things matching up here. Now, log to base 5 of 5, I'm going to put that into my calculator. Okay, and I'm going to see that that's just a number. Okay, I can put it into my calculator and that's going to give me out 1 plus log to base 5 of x squared. Okay, so now we have this, and we also have our a, so a is equal to 1. Only problem now left is we want log to base 5 of x with a number in front. This squared here is in the way. So we can use this rule here. If we have a square, or if we have a power, we can just put it down in front. So we have log to base 5y is equal to 1 plus 2 log to base 5 of x. Now our equation matches up exactly as what we wanted. So we wanted log to base 5y is equal to a plus b log to base 5x. So we wrote down earlier that a is 1. Now we can say that b is 2. Okay, so not too bad a question. I think once you got it started, it was okay. And it's also using the rules backwards, which we may not have seen before, but if we can use them to solve, we can kind of use them then working the other way as well. Okay. Moving on to part 2 then. So it says hence or otherwise. The second question says that. I'm immediately thinking that I'm going to want to make a link to the previous part. Find the real values of y. So that's going to be important. I'm going to put a little mark there to show we're looking for y. So our last answer should be y is equal to a number. So we're looking for the real values of y, for which log to base 5y is equal to 2 plus log to base 5 of 126 over 25x minus 1. So first I need to look for my link to the previous part. So we have a log to base 5 of y here. But in the previous part, I already found that log to base 5 of y is equal to 1 plus 2 log to base 5 of x. So I'm going to change that. So anywhere I have a log to base 5y, I'm going to let that equal to 1 plus 2 log to base 5x. So now I can rewrite my question as 1 plus 2 log to base 5x is equal to 2 plus log to base 5 of 126 over 25x minus 1. Okay, now I have logs at different sides of the equal to sign, I have numbers at different sides of the equal to sign. So I'm going to tidy it up, rearrange it, so I have all my logs at one side and I have my numbers at the other side. So what I'll end up with then is I have 2 log to base 5x minus log to base 5 of 126x all over 25 minus 1 is equal to 2 minus 1, which is 1. Okay, now I'm subtracting. I'm pretty sure at some stage I'm going to have to use this rule. Okay, but I need to see, okay, can I use it directly? No, because of this 2 in front here. So I need to use this rule here to get rid of the 2 from in front. I'm going to make it a power. So it's log to base 5 of x squared minus log to base 5 of 126 over 25 x minus 1 is equal to 1. Now this matches up exactly with this, so I can divide. So it'll be log to base 5 of x squared divided by 126 over 25x minus 1. Okay, this might look a little tricky to solve, but we can see when we get rid of the logs now, it'll actually all come together nicely. So again, I'm at this kind of stop point now. What I'm looking for, the x, okay, is stuck inside in the log. Anytime I get to this stage, I need to use the top rule here in the right hand corner to go and change it to an indice or index form. So I have my a, my y and my x, and we need to change it into the a to the power of x is equal to y. So that will be 5 to the power of 1 is equal to x squared all over 126 over 25 x minus 1. Okay, right now this looks really messy. I don't like the fraction, so I'm going to get rid of the fraction by multiplying 5 by the bottom of this fraction here. So it'll be 5 multiplied by 126 all over 25x minus 1 is equal to x squared. Multiply this 5 in, that will give me 126 all over 5x minus 5 is equal to x squared. I still don't like having a fraction in my question, so I'm going to multiply everything by 5. So I'll end up with 126 minus 5 by 5 will be 25 is equal to 5x squared. Now, this to me looks like a quadratic because I have an x squared, x and a number. So we're going to write it as a quadratic. Just go up here to the right hand side. So it'll be 5x squared minus 126x plus 25 is equal to 0. Now, it is probably possible to solve this using factorising, but I'm just going to use the minus b forms. This is my a, my b, and my c. And your minus b form is at the front of your formula book. So we have x is equal to minus 126 plus or minus square root of minus 126 to be squared minus 4 by a by c all over 2a. Okay, so we'll have our plus side and we'll have our minus side. Now, just put this into your calculator nice and carefully. You can put it in one go. Just press the fraction button first is the easiest way to go about it. Minus 4, 5, So I get out one answer is x is equal to 25. When I put in the plus, and then I'm just going to go back up and change that to a minus, I get out x is equal to 1/5. Okay, now at this point a lot of people might think, great, I've done all this work and I'm done. Always important to go back and read your question. We're looking for the real values of y. Okay, I have two values for x. Okay, so now we need to find a way to make those x's y's. Okay, if we go right back up to the top of the question, it says y is equal to 5x squared. Okay, so I'm just going to do that. So y is equal to 5 by 25 to be squared, or y is equal to 5 by 1/5 to be squared. So here I get out y is equal to 3125, and here I get out by 1/5 to be squared. That actually gives me out 1/5 as well when I put that into my calculator. Okay, so my two answers then are 3125 and 1/5. Okay, slightly trickier question there. I think that may be the hardest question we've seen. Especially the second part, just reading the question carefully is important, making sure we know what letter we're looking for at the end. So we were looking for y's, you got your x's, you've your hard work then done. So make sure you go back and read the question just to make sure you get full marks for it, that you've your answer written in the correct form. Another question now, going back to 2016. So this is kind of similar, so we need to use our laws to kind of manipulate it to make it look like the form in the question. So we're told that log to base a of 2 is p and log to base a of 3 is q. Write each of the following in terms of p and q. So in terms of p and q just means we want p and q in our answer. Okay, we're told information about log to base a of 2 and log to base a of 3. Okay, so we want those in our question. Okay, so our first thing we're given is log to base a of 8/3. Okay, now I think, what can I do with that? Okay, so I look at my rules. What I have looks really like that. Okay, so what we're going to do, we're going to split it up and we're going to subtract it. We'll see where that brings us. So then we're left with log to base a of 8 minus log to base a of 3. Okay, log to base a of 3, we have this part of it out already, that's equal to q. So already I have half of my answer minus q. Okay, now we need that log to base a of 8 to change. Okay, ideally I want it to look like log to base a of 2. Now, how can I change an 8 into a 2? Okay, what I could write this as is log to base a 2 cubed minus q. Okay, now I've log to base a of 2, just this cubed is in the way, but I can use this law here, the third one, to bring down that power out in front. So we're left with 3 log to base a of 2 minus q. Now here we have our log to base a of 2, so we are going to replace that with p, so we'll be left with 3p minus q. Okay, so that is log to base a of 8/3 written in terms of p and q. Okay. Moving on to part 2 then, you can see it's quite a similar question. Again, we're trying to get log to base a of 2 and log to base a of 3 out of this so we can write it in the form p and q. Okay, so first thing I'm going to get rid of that division and subtract them. Okay, now always keep an eye on what we're looking for. So we're looking for log to base a's of 2 and log to base a of 3. Okay, first thing I'm just going to go off to the side here and do a bit of rough work because there will be quite a few changes here. I can immediately see log to base a of 16. Okay, we want this to be a 2. I can write that as log to base a of 2 to the power 4. Okay, 2 to the power 4 is 16. And I can bring down that power then, so that'll be log to base a of 2 and the 4 down in front. Log to base a of 2 is p, so that would just equal 4p. So log to base a of 16 is 4p. Now when I look at this, okay, it's log to base a of 9a squared. I can split that up, okay, because the 9 and the a squared are being multiplied by each other. So I can say that that is log to base a of 9 plus log to to base a of a squared minus, and we've already changed log to base a of 16 to 4p. Okay, now log to base a of 9. We don't know anything about log to base a of 9, but we do know something about log to base a of 3. So instead of writing log to base a of 9, I can change that 9 to 3 squared. Plus, now, don't know what I'm going to do here yet, but I do know I can get rid of that squared and I can bring it down in front. So that'll be 2 log to base a of a minus 4p. Okay, now what can I do with this here? Okay, I can immediately see I can bring down that power, and then I'm actually going to be left with log to base a of 3, which is what I want. So I can bring down this power, so that'll be 2 log to base a of 3, okay, plus 2. Now, just a little side note here, okay, so this is a handy rule to be able to know. So if you have log, I'm just going to pick a random number here now, log to base 5 of 5, that's equal to 1. If you have log to base x of x, that's just equal to 1 as well. So if your base and the part in the log are the same thing, your answer is always 1. So log to base a of a is just going to be 1. Minus 4p. Okay, and we know log to base a of 3, if I go back up to my question, is q. So we have 2q plus 2 minus 4p. I'm going to rewrite that. So we have 2q minus 4p plus 2. Okay, so that's our answer written in terms of p and q. Now we're going to look at the real life examples that come up that link logs and indices. Okay, these are super common questions. They come up nearly every year, and we're going to go through 3 of them, and I hope you'll realise the similarities between them. Okay, so they come up all the time and they're nearly always solved with the same methods. Okay, so first we'll read the question, figure out what this one is about. They tend to be about anything, and you don't need to know, like this one is about injections of a medical drug, but they can be about absolutely anything. Don't let that throw you. Okay, so Alex gets injections of a medical drug. Each injection is 15 milligrams of the drug. Each day the amount of drug left in Alex's body from the injection decreases by 40%. So the amount of drug in milligrams left in Alex's body t days, so this is an important piece of information here, that t is in days, after a single injection is given by that formula. So 15 multiplied by 0.6 to the power of t. Found the amount of the drug left in Alex's body 2.5 days. Okay, so this is going to be my t after a single injection. Give your answer in milligrams, correct 2 decimal places. So all I'm going to do is I'm going to sub in 2.5 for t. So it'll be 15 multiplied by 0.6 all to the power of 2.5. Okay, I'm going to pop down to my calculator. 15 by 0.6 to the power of 2.5. I get out 4.1828. We wanted the 2 decimal places, so that'll just be 4.18, and remember our units are milligrams. Okay, you can get that by reading back through the question. Okay, so that was fairly straightforward, just subbing in a number instead of our t. Now, the next part now is going to involve a little bit more work, okay, as you'd expect, because you're moving from part A to part B. So after a single 15 milligram injection, so how long, okay, is the key bit there. So how long, that means we're looking for t. Okay, so we're looking for time. Okay, how long after a single 15 milligram injection will there be exactly 1 milligram of the drug left in Alex's body? So we have our formula 15 multiplied by 0.6 to the power of t, and we want that to equal 1. Okay, we're looking for t. Remember, in general, unless you're dealing with simultaneous equations, you can only have one thing missing from your equation. So in this case, it's our t. So I'm going to do a little bit of work here first. So we have 0.6t to the power of t. We're going to get rid of that 15, so divided across is equal to 1 over 15. Now, mentioned this a couple of times, went back to our favourite rule up here. So when we have something, whatever we're looking for, in this case it's t and it's stuck as our indice, we need to move to logs. Okay, so right now I have a to the power of x. So I have something that looks like this. This is my a, this is my x, and this is my y. And we want to change it into log to base a of y is equal to x. So I'm going to rewrite this as log of base 0.6 of 1 over 15 is equal to t. Just pop that straight into my calculator. So log to base 0.6, 1 over 15 is equal to, so t is equal to 5.301. Okay, it says to one decimal place, so t is equal to 5.3 days. Okay, so after 5.3 days, there'll just be exactly 1 milligram left. Okay, this is a super common question. I'm going to do the next question now, and we're going to show that it's extremely similar. So this question then is about power supply to a space satellite. So if you can see what I mean now, these questions can be about anything, but they're all roughly the same. So we take the same approach to them all. So the power supply to a space satellite is provided by means of a generator that converts heat released by the decay of a radioisotope into electricity. The power output in watts may be calculated using the function. Okay, so W of t, that's our power output, is equal to A e to the power of bt, where t is time in days from when the satellite is launched into space. The initial power output at the launch of the satellite is 60 watts. Okay, given that after 14 days the power output falls to 56 watts, calculate the value of B. Okay, so we have our power is equal to A e to the bt. Okay, here we're looking for B. Okay, so we need to know everything else. So the power, we're told, is 56 watts. 56. Time, there's 14 days. And we know E, remember E has a value. E is actually the number 2.718 ... It's kind of like the number pi. Okay, same idea, but just press the button on your calculator. So we know what E is. And then A, that'll be our initial value. That'll be 60. Okay, so we know everything except for B, so we can solve it. So we'll have 56 is equal to 60 e to the power of B multiplied by t, which is 14. Okay, so 56 is equal to 60 e to the 14b. Okay, very similar again. I'm going to get rid of that 60, so divide the 56 by 60. Okay, so it's 56 over 60 is equal to e to the 14b. Now, very similar again. I'm just going to get my formulas. We have what we're looking for trapped inside in the power. So we're going to change to logs. So this here is my... Now, this time it's actually written the other way around. I'm just going to flip it just so we're looking at it the same way as it's in the formulas. So what we have e to the power of 14. B is equal to 56 over 60. So this is my A, this is my X, and this is my Y. Okay, so we're going to write that as log to base A of Y is equal to X. Okay, so we have log to base E of 56 all over 60 is equal to 14b. I don't want 14b, I just want b, so I'm going to divide it by 14. So we have log to base E of 56 all over 60 divided by 14 is equal to b. So b is equal to, we wanted 3 decimal places, so I'm going to pop down to my calculator. I get out, now in my calculator it's giving me minus 4.928 by 10 to the minus 3. Okay, that means, okay, I need to move my decimal place, so that's in scientific notation. So I need to move my decimal place 2 places minus. The minus power means that it is a really small number, so I need to move it 3 places to the, move my decimal point 3 places to the right. So we're going to end up with minus 0.00498. We want it to 3 decimal places, so that'll be minus 0.005 as my answer for B. Okay, just be careful there, scientific notation. You can always check, like you can practice those. What you can do as well is, okay, put in minus 0.005 in your calculator and press the equal to sign and the SD sign to change it into scientific notation, and it matches up, so it's still by 10 to the minus 3, so you know you're correct then. Okay, so that's our value for B. We're probably going to need that in the next part. So what I can do, I can actually rewrite my formula as power is equal to 60 e to the, what was that, minus 0.005 t. Okay, I haven't even read my question yet, but I probably know I'm going to need that. Okay, they didn't get me to find that just for the fun. I'm going to need it for the next part. So the satellite cannot function properly when the power output falls below 5 watts. After how many days will the satellite fail to function properly? Okay, so we're going to let our power be 5, and we're going to solve for t because we're looking for time. So it'll be 5 is equal to 60 e to the minus 0.005 t. Divide both sides by 60, so it'll be 5 over 60 is equal to e to the minus 0.005 t. Again, same situation here. What we're looking for is in the power, so we need to change it around. Again, I'm just going to reverse this just so it matches up with the formula. So e to the minus 0.005 t is equal to 5 over 60. This is my a, this is my x, and this is my y, and we want to write it as log to base a of y is equal to x. So it'll be log to base e of 5 over 60 is equal to minus 0.005 t. Divide both sides by minus 0.005. T, so t is equal to 496.98. Okay, so it will equal, the power will equal 5 after when time is 496 days, 0.98. So when time is equal to 497 days, the power output will be below 5, which means it won't work. Just going to do a quick check there to see if I'm right. So power, we're going to find the power after 497 days. So 0.6 e to the power of minus 0.005 by 497. Down to my calculator, so 60 e to the power of minus 0.5 by 497 days. Okay, that's going to give me 4.999. Okay, so after 497 days, or when they reach the 497th day, it's going to be below 5 on the day 400. So that's the end of this Saturday session. So I'm just going to leave you with some final tips. So just practice using the formulas, get familiar with how they're written in your formula book. Okay, don't just rely on getting them from your textbook. Practice using your formula book because that's what you'll have in your exams. And then that really important rule moving between logs and indices. If what you're looking for is trapped in the log, change to indices, and vice versa if it's trapped in the power. Okay, so practice moving between them. And then practice the exam questions, especially those real life examples. You will really start to notice a pattern on how the questions are asked. So practice at those. Okay, best of luck. I really hope you found this session helpful.